Welcome to the deep dive. Today, we're cutting through the noise. We're going straight for the architectural knowledge you need right now. So if your mission is to get fluent in those core GitLab collaboration tools and really grasp the engine driving your CI/CD pipelines, you are in the right place. We've gone to your sources, the articles, the docs, all the technical notes, and we're pulling out the essential nuggets. We're talking snippets, wikis, the Web IDE, and then we're heading straight to the engine room, Docker.
Exactly. And the goal here is that when you leave, you don't just know what these tools are, but how they're actually built. We're focusing on those technical distinctions, the little secrets in the architecture, the specific keywords that really make it all click. That's the shortcut to being genuinely well-informed.
Okay, let's unpack this. We'll start with what I call the quick hit tools. So moving away from, the main repository to just sharing small reusable bits or making lightning fast fixes. First up, snippets. It seems like the obvious choice for sharing a small utility function or maybe a config block, right? It's all about convenience. But, why wouldn't a developer just use a GitHub gist or some other paste bin?
That's a great question. On the surface, they do look very similar.
Right.
But there is a key technical distinction right inside GitLab. First, you have two types. Personal snippets, which are just tied to you, and then project snippets, which live right alongside a specific repository. But here's the bit that really elevates them. Snippets are fully version controlled, and this is crucial. They are inherently multi-file.
Hold on. Multi-file. That's interesting. I always picture a gist as, just one file. Why is being able to handle multiple files such a game changer?
Because real code is rarely just one file. Think about a small Docker Compose example. You probably need the YAML file and a little shell script to run it.
Okay, sure.
If you share those separately, they're disconnected. With a multi-file snippet, you can package the config, the script, maybe even a quick readme all together. It's a single, coherent unit with a history.
Ah, okay, that makes the distinction crystal clear. So it's not just a place to paste text. It's more like a tiny, portable, version control project, for examples.
Precisely. It turns a quick share into a reusable, governable asset.
All right, let's move to the second quick hit tool. The Web IDE. This one is all about quick fixes. You know the scenario, right? You spot a typo in the docs on a Friday afternoon, or a teammate just needs a variable name changed. And we all know the pain of leaving the browser.
Yeah.
Have to pull the code, wait for your local IDE to load, find the line, make the change, commit, push. That whole cycle. It's an efficiency killer. We call it context switching.
Oh, it truly is. It's a measurable drain on your focus. I'd argue the Web IDE is one of the most important collaboration features because it's essentially a multi-file editor that lives right inside your browser, just eliminates all that friction.
I can think of so many times I've clicked away to make a one-line fix, and before my editor even loads, a notification pops up, and suddenly I'm answering email or doing something totally different. 20 minutes just disappear.
That is the exact problem the Web IDE solves. The whole point is to keep you in the flow inside the GitLab environment. You can edit multiple files, you get syntax highlighting, and you can commit directly to the branch, or even create a new one without ever leaving that browser tab.
So for those little documentation updates or typo fixes that might be blocking a deployment, it just streamlines everything.
Exactly. It keeps the developer's attention right where it needs to be.
Okay, so we have snippets for quick sharing, Web IDE for quick fixing, but those are for small, atomic pieces of code or knowledge. What about when you need to store the deep knowledge? The architectural diagrams, the user guides, the really complex stuff.
That's when we shift focus to the GitLab wiki. Every project needs that central source of truth. But there's an architectural insight here that many people miss, and it's crucial for understanding how powerful the wiki really is.
Okay, I think I know where you're going with this. It's not just a normal wiki, is it?
It is not. The key architectural insight is this. Every GitLab wiki is actually set up as a separate Git repository.
Wow. Really?
Right? It's not just some page in a database. It's a full-fledged repo that lives right alongside your main project code.
But isn't that a bit of overkill for someone who just wants to write a user guide? Why make documentation a Git repository?
Well, it might seem like it, but that complexity is what enables really powerful features. Because it's Git, you get a full revision history, you can revert changes, and most importantly, you can clone it locally.
Ah, okay, cloning it locally so you could use your own editor.
Exactly. Think about a technical writer who loves their local Markdown editor. They can pull the entire wiki down, make huge structured changes offline, and then just push it all back up in a single commit. You get to use your favorite tools without losing that central source of truth.
That is a massive distinction.
Hmm.
And since it's a repository, I assume access control is a big deal. What do the sources say about who can actually contribute to the docs?
Yeah, the access levels are pretty straightforward. Guests, so users at the lowest level, can usually view the wikis. That's great for transparency.
Mm-hmm.
But to actually edit the content, create new pages, and commit those changes, you generally need at least developer access in the project. That makes sure critical docs aren't changed by mistake.
So the wiki is basically just another Git repo with a friendly web interface.
That's fascinating. Okay, that's a perfect pivot. We've covered the user-facing tools. Now let's go into the engine room, the tech that actually takes those commits we made in the Web IDE and runs all the automated jobs. We're talking about Docker and CI/CD.
Right. This is where the magic becomes pure engineering. Docker is really the silent workhorse behind all of this. To a developer, a pipeline just passes. But underneath, Docker is providing the clean, isolated world that makes it all possible. It's the absolute foundation for GitLab CI/CD. So why is that isolation so critical? I mean, couldn't you just run the build scripts directly on some server?
You could, but that road leads to chaos. It leads to what we call dependency hell.
Right.
Imagine your Ruby test suite runs, and then a node deployment job runs right after on the same machine. You could have dependency clashes, version conflicts, leftover files from the first job polluting the second. It's a mess. Docker solves this with perfect, reproducible isolation. The main way we do this is with the Docker executor. When a job starts, the executor spins up a totally fresh container, a clean workbench, just for that job.
And when the job is gone.
The whole workbench is destroyed. Nothing is left behind. It guarantees your pipeline results aren't just an accident of what ran before. That reproducibility is everything.
That makes sense. But if the executor is creating this perfect environment, how does the job know what kind of environment to create? How does it ask for, say, Python 3.10 instead of Node 18?
That's handled in the heart of the pipeline, the configuration file, the .gitlab-ci.iml. This is where the technical link to Docker lives, and it's something every developer needs to know. You specify the exact environment with one simple but absolutely vital keyword, image.
The image keyword.
That's it. In your .gitlab-ci.iml, you define a job, and then you use the image keyword and tell it the name of the Docker image you need, like image.python 3.10-slim. The Docker executor sees that, pulls that image, and runs everything inside that exact container.
So the image keyword is the direct instruction. It's the order telling the Docker executor exactly how to build that isolated workbench.
Exactly. It's the technical contract that gets rid of the whole, well, it works on my machine problem.
Okay, let's synthesize this. We started with the flow.
Sure.
A developer uses the Web IDE for a quick, efficient fix. That commit triggers the pipeline. The pipeline uses the Docker executor, which instantly builds a clean, reproducible environment based on the specific image keyword in the config. And if that developer needed to update the docs after the fix, they'd jump into the wiki, knowing they're just committing to another version-controlled Git repository.
It's a complete integrated cycle. Every tool we talked about reinforces the others, all optimized for velocity and relying on those core principles of Git and containers.
That brings us to the end of our deep dive. We've covered the tools and the engine, but we really focused on those architectural nuggets. To cement them one last time, snippets are version-controlled and multi-file. The wiki is a separate clonable Git repo, and the CI/CD foundation relies on the Docker executor, all configured by that crucial image keyword.
Right. And this raises a final question for you to think about. We established that the Docker executor gives you that perfect, isolated workbench. But what if you couldn't use it? What if you were forced to use, say, a shell executor, which runs jobs directly on the host machine? What specific new security and dependency challenges would you immediately face that the isolated Docker world just completely prevents?
Think about that. No clean slate. The implications are significant. Take this knowledge, apply it to your next project, and we'll catch you on the next one.